last video here, I think this one should pretty much tie it all together. We are looking for an overall, I guess you could call it, or at least what the directions call it, is attenuation over shielding and distance. Okay, so like I said, this one ties it all together here. We're going to go dose rate and time, we're going to use half value, we're going to use inverse square law, everything's going to be tied in there. So, a couple of things that we'll see that you haven't seen before, maybe you have, just haven't said them out loud. But other than that, everything should pretty much be a straight ahead type equation or type problem. So, like I said, just tying everything together here. Iridium 192 source, 112 curies new, is 86 days old. We want to know the curies today. Okay, decaying source or half-life here, we're just going to do this step by step. So I'm going to write it out here kind of as we would. 112 curies, we want to divide that by 2 for half-life. We know it's 86 days old, and 75 days is the half-life for iridium. So, stand back here so you can see the problem. 112 divided by 2 to the power of 86 days divided by 75. That tells us that we have roughly 50.58 or 59 curies today. Okay? So we would put that up here. That's going to be in blank number 1. And we can go ahead and label that curies. That's no big deal. I'm not going to label it down here though because we're just going to keep it in a problem. Now, we want to go from curies to Rankine. So, multiply by 5.2. That comes from right there, 5.2 Rankines per hour per curie. That puts us at 263.051 in my calculator. Okay, so I'm just going to write that up here. 263.051 Rankines per hour. Okay, now we need millirankines per hour, so that's a simple move of the decimal or multiply by 1,000. 263,051 is what we've got there. So I'm going to park that up here. MR per hour. Okay? Source is collimated using a 7 half-value layer collimator. Okay? Right here. Half value life or something like that, half value. So all we do is divide this guy by the power, or divide that by 2 to the power of 7. Okay? Because we have 7 half-value layers. So right there. That brings it down to, I'm just going to write it over here, 2,055 Rankines, sorry, that's millirankines at 1 foot. Okay, right there, 2,055 millirankines at 1 foot. So now the source is going to be exposed 12 minutes per hour. Dose over here. Okay, we'll multiply that by 12 over 60. That brings it down to 411.02 millirankines per hour. Okay, right there, 12 minutes per hour. 411.02. Now we've got to move out 12 feet. So we're going to use this guy. Easiest way to do that, because we know we're already standing at 1 foot. You can write it out if you like. If you wanted to, it'd look like this. 411.02. We're going here. We're going out 12 feet squared. We're at 1 foot squared. This times this divided by that. Okay, you can just shorthand it right there. So 411 divided by 12 squared brings it down to 2.58 or 2.854. Sorry. And these are just the numbers that I'm keeping in my calculator. That's still per hour. Wall is 8 inches thick, so now we need to decay through the wall, or attenuate through the wall is a better word. Divided by 2 to the power of 8. And this is just a number you probably wouldn't know it off the top of your head unless you've seen it already. 1.75 inches of concrete is a half value thickness for iridium. Okay? So if you have 100 Rankine per hour, you decay through 1.75 inches of concrete, or you attenuate through 1.75 inches of concrete, and now you come out on the backside with 50 MR. So, 2.854 divided by 2 to the power of 8 divided by 1.75. That's just how many half values we have. So, divided by 2 to the power of 8 divided by 1.75. Okay, that brings it down to 0.120. Okay, and you could do that, still MR, if you went, you know, just trying to think common sense. Let's just say that's roughly 2 inches. So if we had 3 MR right here, we had 8 inches and that was 2, you know, just rough numbers. So if we had 3 and we divided that in half, okay, let's just figure this out. That would be 4 half-lives. So we divide that in half, that would be 1.5, okay, 0.75, so on and so forth. So you can see it's going to be down there getting close. Just rough numbers. Okay? So get rid of that. Now we're on the back side of the wall, and we're going to go another 15 feet back. This is where people kind of get confused. I'm going to keep this guy here, but I'm going to erase those numbers. I'm going to drive that back up over here so we can kind of park it next to each other and see what's going on. We are already at 12 feet 8 inches. Okay, here's our source. There's my little source drawing. Here's our concrete wall. We're going back another 15 feet. Okay, I guess we could shorten this up a little bit. Need one side shorter than the other. So let's say this, 12 feet. This is 8 inches. That's another 15 feet. So that's 27.67 feet, give or take a little. This is the total distance we're going. Okay? So we know that's going right there. And we have to add this wall in because it's part of the equation, it's part of the problem. Okay, 15 feet is where we're headed. We're headed another 15 feet, so that's going to be our distance 1. Okay, but it's still going to be squared. And the reason for that is that's where we're standing, and we're considering that to be our new distance 1, and we're decaying over that distance further. So, our current value of where we are right now is 0.120, and we're looking for our intensity 2, or that furthest intensity back, right there. So, 0.120 times 15 squared, still work the exact same way. Divide that by 27.67 squared. I come out with a value of 0.035 MR per hour. So this guy right here, 0.035 MR per hour. So that whole problem said this. If we had a worker, he was using Iridium 192, it was 112 curies, 86 days old, we have 50 curies roughly today. Okay, that converts to 263 Rankins, 263,000 Rankins. We slap a collimator over the top of it. That drags it down to about 2,000 MR. Okay, we cut the time way down to 12 minutes per hour. That's 411. Okay, the source is 12 feet away. So now we back up. We're at 2, which is, this is a 2 MR boundary, or pretty close to. Back side of the wall, 0.120. We go back another 15 feet. Decays even further, way down to 0.035 MR per hour. Very, very good number to be dealing with. So no problem there. If you have any questions, feel free to ask, feel free to email. I don't have a problem with that. But if you need to, go back over that and kind of see where I got all those numbers. And don't feel bad if you have to go back and watch the video 2 or 3 times. I know that might not be so pretty for you, but you have to see me anyway. So go ahead and watch it over again if you need to. If not, it shouldn't be too big of a problem. Just give me an email or something like that. Okay? Good luck and good calculating.